So we start off with the sum of k equals 1 infinity, k to the x to the k. So then we set it into a sub k, then a sub k plus 1. So it's k to the x equals k times the absolute value of x to the k. And after this we have a to the k plus 1. And then this is the absolute value of a to k plus 1. Then this is absolute value k plus 1 times k to x plus 1. And this equals k plus 1 times the absolute value of x to k plus 1. And then if we do this, we do the absolute value of x. No, sorry. And then we go up here, the limit of k approaches infinity, k plus 1 times x times k times the absolute value of x to the k. And this is the k plus 1 here. And then down here, one of the k's cancel, so we just have k plus 1 times the absolute value of x times k. And then down here, we have the limit of k approaches infinity, k plus 1 times over k. And then we do the hospital's rule, or the L'Hopital's, because it's infinity over infinity, because if you put infinity here, it's infinity over infinity. And then we just have the absolute value of x left. The limit is k approaches infinity, the absolute value of x times 1, which is just the absolute value of x. So then, if we go over here, we have to test it on both the endpoints, because with 1 and -1. So to test it at 1, k times 1 to the k equals just k. And then, k to the k. And then down here, we have f times -1. And this is just k times -1 to the k, which should be negative k to the k. So, alternating series, k is greater than 1, or k to the k is greater than 1, and negative k to the k is less than 1. So if we follow this, it converges absolutely on the interval -1 to 1, and then and because it r is greater than 1, so it diverges everywhere else. And that is the end.
Nope, keep going. All right, so we're checking the endpoints. Stand back.
I did do that.
No, let's talk about it. -1 to the k is 1, so you have the sum from k equals 1 to infinity of k.
K to the k.
Nope, just k.
Okay.
Okay, so when I take this, what kind of series is that?
Alternating series?
Nope.
Whoa.
So we're just summing over k. So if I want to use the divergence test, I take the limit as k goes to infinity of k. What does that equal? So as k approaches infinity, this is infinity, which is not equal to what?
Not equal to 1.
0.
0, okay.
So this does what?
Diverges?
By the divergence test.
Okay.
Also, when you're checking endpoints, you want to tell me what test you used. So that means on my interval, this has to be an open. So let's check the -1. So now we have k times -1 to the k, which is what kind of series?
The same one as...
Nope.
Okay.
What's the -1 to the k tell you?
To
We want to check if it's
the
what?
power.
-1 to the k. We want to check if it's...
Converging or diverging.
Starts with an A.
Alternating series.
Alternating. So it's alternating. All right. And then a sub k would equal k. Is that positive? When k is greater than or equal to 1?
Yes, it's positive.
Okay, so we have alternating with positive. So we know it's an alternating series. So we're going to use the alternating series test.
Okay.
So we need to check two things. We need to check if it's decreasing. What's the derivative? If f of x equals x, what's the derivative?
1.
Positive or negative?
Positive.
So this function is doing what?
Increasing.
Yep, so f is increasing. So it does what? It diverges by the alternating series test.
Okay.
Which means you also need an open here.
Oh.
Okay? Now you can stop.
Okay.